All right, time to begin. We have Leslie and Gabby Missum. So we're going to start with the clicker question. Why do we see phases of the moon? Something we talked about during the lecture and lab yesterday. Choose you to stay. Still waiting for Mariah and Ashton. All right, everyone's answered. Oh, I have it on white. All right, we had 1, 2, and 3. I am going to call on Ivy and ask you yes or no for A.
No.
No. Why not?
Because it's not what I do.
Well, yeah, but what's your reasoning?
Asking we see different sides of people. Well, I mean, I don't know. It just didn't seem right.
Just didn't seem right.
Yeah. I'm not explaining it. I mean,
It is incorrect.
Yeah.
What's making the moon bright in the sky? Reflection of the sun. It's not that one side of the moon gives off light and one side doesn't. It's the reflection of the sun. And so we actually always see the same side of the moon. Remember I talked about yesterday that it's tidally locked. So one side of the moon is always facing us. So whether it's light or dark, full moon or new moon, we're still looking at the same side. So we're looking at the same side to begin with. And even at that, it's not the side you're looking at that makes it bright or dark. Okay, nobody said B. What's wrong with B?
we don't go around.
We don't go around the moon. Okay, and there's the sides problem as well. Okay, one person said C. Ashton, what do you think about C?
Well, no, I think it's wrong. No, because we don't go. Wait.
It's the correct answer.
I chose this is correct.
Okay, we are moving, well, the moon is moving around us as both of us move around the sun together in concert. And we see whatever side of the moon is facing us, which is always the same side. And if that's facing the sun, it'll be lit up. The next one was wrong because, again, we don't go around the moon. And it's not our shadow. What do we call it if the moon goes into our shadow? That's right. That would have been a lunar eclipse. So if it asked what causes a lunar eclipse, E would have been the correct answer. But it was asking for the phases of the moon. So just as a reminder, here's the picture showing how you get those phases. For any given 24-hour period, you could treat the sunlight as always coming from the same direction. The Earth is rotating, the moon is orbiting around, and you would have those relationships geometrically for the phases. So if it's a first quarter or third quarter moon, and you're going to point one finger at the sun and one finger at the moon, what angle are you making with your two arms? If it's first quarter. Look at the picture. First quarter. If one finger's pointing the moon and one's pointing the sun, what's the angle?
90?
9 degrees. You would have one finger pointing that way, one finger pointing that way at first quarter, and likewise at third quarter, you have a 90-degree angle between the direction toward the sun and the direction toward the moon. Thus, the half of the moon that's lit up, you see one half of it is that, and one half is not lit up, if it's a first or third quarter. In these phases, which phase is it going to be if we have a lunar eclipse? Remember, we just had from the previous slide that lunar eclipse occurs when the moon is in the shadow of the Earth. In which position can the moon be in the shadow of the Earth? Not new. How can the Earth cast a shadow before the light's gotten to the Earth? It's going to be 5. It's going to be the full moon. So that's the only time, the only geometry that will allow for a lunar eclipse. But remember, it doesn't occur every full moon because the moon is not orbiting the Earth on the same plane that the Earth orbits the sun. But when the moon is crossing the plane the Earth orbits the sun, then you have the eclipses. But lunar eclipses are always full moon. Conversely, what phase will you have for a solar eclipse? Now, how many people have watched the movie Apocalypto? Really? It's a fairly recent movie. Well, in the movie Apocalypto, the whole story is about, I can't remember what country it's in, but it's, I believe, in South America, where we're back in time when they believe that solar eclipses were very bad omens. They had stories like the gods are angry with us, and so they're taking away the sun. Or the gods are eating the sun, or something like that. Many cultures have stories like that because it kind of makes sense, because all of a sudden the sun has something taking out pieces of it. And the religious leaders, who one has to assume have figured this out, made the most of it. They said the gods are angry, let's appease the gods. So in the movie Apocalypto, the priests are sending out all of the soldiers to capture natives that they are then beheading until the sun starts growing again. It starts coming back. Then they say, we've appeased the god, yay. And yes, cultures did this. It's historically accurate in that regard. And so they have the solar eclipse. What phase should the moon be if it's a solar eclipse? Say it out loud. It should be a new moon. So the whole story is about, these people. That's half of the movie, is them gathering up these people. They're trying to evade, and then they're taking them and they're chopping off the heads.
Actually, I think I still see that one. Remember, right?
The hero of the movie is just about to have his head chopped off when the sun starts coming back. And so then they say, okay, you're free to go, but they want to have fun with them. So they make them start here. They say, hey, you can run, and if we shoot you, well, you die. And so they're making sport of killing all of these people because, yeah. And so this one guy manages to evade them, and then they decide they want to hunt him down because he must be a great, prey to try to hunt. And that night, it's a full moon. What does this tell you? That Mel Gibson didn't know anything about his science here of what creates an eclipse. Because you can't have a full moon the night following the solar eclipse. It's going to be a full moon, a new moon. So I always kind of have to point this out because, you see things in popular media and often you just don't think, hey, that couldn't happen. But we know better. Okay, we're going to talk about the outer planets now. So we have low density outer planets. The densities of the outer planets are all under 2 grams per centimeter cubed. They're all much, much bigger than the Earth. And the spacing between the planets is likewise much, much bigger than the spacing between the inner planets. How close are they? Well, we obviously have 2 planets between us and the sun. So we have 3 planets within the distance we call an astronomical unit, the average separation between the Earth and the sun. And then Mars is another about, half or 3/4 of an astronomical unit away. So it's closer than 2 times the distance to the Earth. Then the next one, Jupiter, it's like 10 astronomical units out there. So Jupiter is like, 6 times, 5 times farther from the sun than Mars is. So it's much bigger spacings out there. And we have the order Jupiter, Saturn, Uranus, Neptune, Jason. See, you could remember that, right? Jason. So let's look at these. Jupiter, it's the first of the outer planets beyond Mars, and it is by far the most massive. The solar system, over 99% of the mass in the solar system is in one location. What's the one location with over 99% of the mass in the solar system? The sun. Because that's what the sun is. It's where most of the mass clumped together. Jupiter is over 70% of the remaining mass in the solar system. So the sun is the vast, vast preponderance of the mass of the solar system. And then Jupiter is well over half of all of the remaining mass. Giant. Its composition, it says here more liquid than gaseous or solid. If you were to fall into Jupiter, you have out here at the exterior gas. And so we've sent probes into Jupiter. You drop the probe, gravity pulls it in, it goes in, the gas gets thicker and thicker and thicker until you reach what we see as the surface. It doesn't have an actual surface any more than a cloud has an actual surface. It's just the gas gets thick enough that you see the gas instead of seeing through it. The same thing is true, by the way, of the sun. So that's what we think of as the surface. Well, the probe goes in deeper. As the probe goes in deeper, it's measuring the types of gases and the density of the pressure until it burned up. Which was, it was known that was going to happen. They had heat shield stuff to try to keep it going as long as possible. One of the things they found was there was a lot less water in the atmosphere than they anticipated. And so, we have scientific... Okay, what's your question?
Oh, no, I'm so sorry. And I was just going to ask, so is there not really a ground to Jupiter? Is it mainly just gas then? Or?
There is no ground, but I'll talk more clearly about it. But the probe found a lot less, like 1/5 the amount of water they expected. How could you explain that? I mean, this is a scientific process. You have a hypothesis, predicts a certain amount of water, they found a lot less. How can that happen? Scientists came up with two possible conclusions. One is that they were unlucky, they happened to hit a dry spot. Number two is their hypothesis must be wrong, and had to go back and try to figure out where it's wrong and adjust the hypothesis to match the data. And honestly, I don't know where it stands on the atmosphere.
I like the first option.
Yeah, we got unlucky. We just have to send 20 more probes.
Very scientific.
Yeah. Once we have 20 probes, we'll know if we were unlucky or if that's really the way it is. So if you go deeper, it becomes more and more hydrogen gas. And the hydrogen gas, because the pressure is getting stronger as you go in, because gravity's pulling stuff in, the pressure gets high enough that it becomes liquid hydrogen. Now, never does it go from gas to liquid. Sounds crazy, right? You start in gas, you end up in liquid, and never does it go from gas to liquid. You're in a range where there is no differentiation between the liquid and gas. There's no barrier that says, oh, this is water vapor, this is liquid water like we have on Earth. It just continuously gets thicker and thicker and thicker until no one would deny it's now a liquid, but never did you actually have a place where it changed phase. So that's something that can happen. It can happen with water, it's just you have to go up to a higher pressure than atmospheric pressure to have water go from liquid into gas without ever changing phase. So there's never a point where you would splash into the liquid surface, but you would be in liquid hydrogen. And the pressure gets so extreme that at some point you would get to liquid metallic hydrogen. Hydrogen that is in liquid form that behaves as a metal. Liquid metals aren't unheard of. Obviously, you can take iron and melt it and have liquid metal. But we have one liquid metal at room temperature. Mercury at room temperature is a liquid metal. It's a metal that has the conductive properties, the optical properties, the heat transfer properties of a metal, but it's in liquid form. And that's what the hydrogen has as you get deep down into Jupiter because it's such high pressure. If you go even further, you get to a rock. So there is a solid surface, a rock, where it's going to have a rock that we believe is bigger than the rock that this Earth is made of. So it's a big rock. But it's under such high temperature and pressure because of all of the gravity crushing down on it that it's not going to look like any rock we would have on Earth. It would be something that would be kind of a novel material is what we call it. Novel because it's not something we see. So that's what you have inside of Jupiter.
So the gravity would be a lot stronger than what ours is?
The gravity out here at what we consider the surface is far, far weaker because you're so far away. Remember that gravitational law, force of gravity is capital G, mass 1, mass 2 over radius squared. Because it has such a big radius at the surface, the force of gravity is reasonably small. But as you get closer, it's much, much, much bigger than anything you can get on Earth. So, things about Jupiter. What do you know from looking at just this picture? What things do you see on this picture that remind you of stuff you already knew about Jupiter? There's what?
I mean, there's one movie.
Okay. She sees one of the Galilean moons. There are 4 Galilean moons. 4 moons that are of the same type that we would consider the Earth's moon. They're not like the Earth's moon, but of the same type. It has lots and lots of smaller ones, but the 4 ones were found by Galileo because they're reasonably big. Now, those 4 moons, named Io, Europa, I can't remember if it's Ganymede Callisto or Callisto Ganymede for the order. Those 4 moons are really bizarre. First of all, the closest one, Io, or Io if you go to Disneyland and watch Michael Jackson with his Captain EO thing. Io, I believe is the correct pronunciation, is close to Jupiter. And it orbits Jupiter. I can't remember its period of orbit, so I won't say something. But it orbits pretty quickly. And then the next one out, Europa, does one orbit in the time that it takes Io to do 2 orbits. It's exactly locked in like that. So just like our moon is locked, so one side is always facing the Earth, we have the same type of thing with these moons between Io and Europa. And you go out to the next one, its orbit is 2 times the one inside, or 4 times Io's. And so you have those 3 are all in a synchronization. Once every 4 orbits for Io, it's going to be lined up with the next 2 planets. The last one hasn't reached synchronization on being 2 times, but it's probably coming in. So that if time were to last long enough, you would have a nice relationship between all of the periods of the orbits. Now, to change the period of the orbit requires the distance of the orbit to change as well. But you're adding energy adding energy or subtracting, depending on which way it's being pulled. Because of the gravitational pull, that's how it changes the orbits. So you have some funny synchronization. Because of that pattern, Io, the closest one, gets really flexed by the next closest one. So that it's constantly being pulled and stretched. What happens to a piece of wire if you bend it a bunch? Eventually it breaks. That's how we used to cut the wire when we didn't have wire cutters when I was a kid. But have you done it physically?
Yeah.
What else happens to the wire besides breaking?
It gets kind of hot.
Gets kind of hot, like really hot, like you burn your fingers hot, right?
Yeah.
That's because you're converting the energy that you're putting in to bend it into thermal energy, making it hotter. And so that's going on with Io, so it has lots of volcanoes because of this flexing. So it has a very hell-like surface with brimstone volcanoes. You go out, and the other 3 of these Galilean moons have ice surfaces. As you go further out, the ice is getting thicker and thicker. And they're believed to have water underneath that ice. And so they're considered good candidates for where life could have formed in our solar system, but not on Earth. That there could be life in the oceans underneath the ice on, for instance, Europa. Yes?
I'm kind of wondering how, if it's so far from the sun, how there can be liquid. Is it because of all that pressure when you're getting to the center, or because
it's not hot out there. And so because it's not hot, it's easier for the gases to condense and stick together and be liquid. You have to have enough gravity to keep it. But yeah, so you have ice, and then you have volcanism, they believe, under the ice to provide the energy source that could allow life to exist. Life on Earth, we know, could exist in those conditions. And so scientists have worked really hard to make sure that they don't contaminate those moons, because they hope at some time they will send a probe to look and see if they can find life living there. And if they have a spacecraft that has landed on Europa, there could be some kind of microbe, some kind of bacteria that survived and then started life on Europa. And they want to see, could life have formed without us seeding it there? Other things you notice here. So we had actually, now that I'm looking at the picture here, I can see better. There is one moon there and one moon there. So we see 2 moons in this picture. The one moon is in front of Jupiter, so it's hard to see. But you see, that's another moon. What about this thing right here?
How big is Earth in comparison? Like, not like size, but like, usually like a circle.
I can't be accurate on this. I don't know. The Earth is probably similar in size, I would guess, to about my blue circle there.
Okay.
I think that's about accurate.
But it's like a big.
Yeah, Jupiter's way, way bigger. What's that thing that I drew around here? What is this thing? It's the great red spot. It's what? Because that's exactly what it is. It's a big cyclonic storm. You have the weather patterns on Jupiter are what we call belt zone circulation patterns. You have wind that's rushing all the way around the planet. And so they call these belts and zones. The belts, just like my belt, pulls in. So the belts are lower atmosphere and darker. The zones are pushed out, like what the belt is not covering, and that is brighter. And so you have the belts and zones alternating bright and dark with winds going opposite directions. And between the belts and zones, the winds going opposite directions, you obviously are going to have prime conditions for making cyclonic storms. And so that great red spot has been there since, I believe, the time of Galileo. He observed it, and it's still there. That's a real tropical storm, right? That's lasting a while. It's got some longevity. That's not the only cyclonic storm. All of these beasts, things like this, those are all cyclonic storms. So it has lots of these storms as well. The atmosphere is 82% hydrogen and 17% helium, 1% methane. Why do you suppose it's so much hydrogen? It's what? Not the volcanoes. Hydrogen is the dominant element in the universe. It would be the primary element in the solar nebula. And these things that formed far enough away from the sun that it wasn't hot were able to hold those light elements. And so it was able to hold on to the most common element. Hence, it's the most common element in the planet. So 82% hydrogen, 17% helium, because helium is the second most common element. These are not the actual ratios in the universe, but they're the most common elements, and they're most common here as well. Methane, ammonia, and other molecules for the rest. The color comes from the methane. Because of its thick atmosphere, there's no daytime, nighttime temperature variation. Here are pictures, and now we can see the proper order. Io, Europa, Ganymede, and Callisto is the proper order. And if you look at Io, you see, wow, yeah, that looks like kind of a rotten egg. And if you were to smell it, it would smell like a rotten egg too, because of all the sulfur and stuff. Europa has an icy surface. Ganymede and Callisto also icy. If you look at Callisto, it has lots of craters. That means that its icy surface has been frozen solid for a very long time, so that it's preserved craters. Ganymede has some, but not as much as Callisto, and Europa doesn't. Now, Europa has lots of things. If you look, this picture is a very high res, and I think I have one coming up that's better. But you can see that there's like lines, and those are cracks in the ice. So Europa has a form of plate tectonics, but with ice plates rather than rock plates. So here is a picture looking at what we believe the interior of Europa is like. Notice I said what we believe. We haven't explored Europa, but we believe that it has a metallic core, just like the Earth does. But that metallic core is not liquid, it's solid, it's frozen. Why would it be frozen? Well, it's a smaller object, so smaller objects they reach equilibrium temperature quicker, even though they dissipate heat less, they can't store as much. And then it has its, shall we call it a mantle? It says the rocky interior. And then a water layer, which is here, which they think is where life could exist. And then, of course, you have the surface ice covering, and you see they've drawn here some cracks because that ice surface will crack and move. Now moving to Saturn. Saturn, what's the obvious feature of Saturn that everybody loves? The rings. The rings around Saturn are ice. That ice varies in size depending on where you are. The largest chunks are about the size of a house. The smallest chunks are just sizes of a grain of sand. And so that's ice that makes up the rings. Saturn is not the only planet that has rings. Did you know that? Yes, Uranus has rings. So does Jupiter, so does Neptune. All of the gas giants have rings around them. But there is a significant difference in the rings of the other three and Saturn's, which is clear. You can see Saturn's rings, you can't see the other ones. The other rings are very thin, and they're made of a different kind of material. They're essentially made up of rock. And so the theory for the existence of the rings is different for Saturn as compared to the other three. The idea is Saturn must have had a comet. Why a comet? Because they're the things that are icy. Must have had a comet that got too close, got inside what we call its Roche limit. And the Roche limit is the distance away from the planet where gravity can hold a chunk together. Because you have a very strong gravitational pull from the planet, you can have the tidal forces, we call it, the difference in force from one place to another, bigger than the gravitational force holding another object together. If that happens and the object's only held together by gravity, that is, if it's a bunch of dirt, not a rock, because a rock is fused, then gravity will shred it apart. And so the theory is that a comet got inside the Roche limit too close to Saturn, and Saturn shredded it. And so that comet got shredded, and now it's perpetually orbiting around Saturn with its remnants. But of course, that's not going to last forever. You have collisions and whatnot, energy is lost, and stuff is slowly falling inward. And so eventually, you won't have any more rings around Saturn. Now, you know I'm a creationist. I believe that God created the heavens and the earth. But I believe that He created the heavens and the earth with a Big Bang. Science has no explanation for how the Big Bang could have started. I believe God set in place the laws of physics and then put in the energy. And then at a much, much later date, He came to this rock and He created life on this rock as described in Genesis. And that's completely consistent with what the Bible says, at least by my reading. Some people will say no. That's their prerogative. We all are going to see things different. So I believe that Saturn is 4.5 billion years old or so. Well, it can't have rings for 4.5 billion years. Creationists will say, see, so it's impossible for it to be 4.5 billion years old because it can't sustain rings for more than something like 10,000 years or something. Well, that's simple for scientists to answer. That just means that it captured and shredded a comet fairly recently, within the last, let's say, 1,000 years. So scientists have no problem with that. That's not an age problem. But creationists, they say, oh, this one thing doesn't fit with my worldview. That is, their worldview is you couldn't have captured a comet to create the ring. And so if it was created with the ring, during formation, then you could still have a ring. That's true, but they're ignoring the fact that science believes it's a captured comet. If you go to the other three, their rings, asteroid rather than comet. Hence, different composition for the material. They're all very thin. That suggests it was a really long time ago when they captured those things and created their rings, so the rings had mostly dissipated. The diameter of Jupiter is about 10 times, or Saturn is about 10 times that of Earth. So if we were to, this one here, I put the number on there so we could say, you know, if we were to draw Earth's, okay, I got smaller at the top and bigger at the bottom to get 10 in there. But that would be a comparison for the size of Earth to Saturn. And it's twice as far from Earth as Jupiter. Big spacings out here. It's the lowest density of all the planets. Its density is less than 1 gram per centimeter cubed. That is, it's less dense. The average density for the entire planet is less dense than water on Earth. It's very low density. Another thing that's kind of cool about it, because of all of the mass in its rings, it's the most oblate of all of the planets. That is, it's got the widest equator compared to its height. So it's the least spherical in shape. Saturn's largest moon, Titan, has been visited. And so we have pictures of the moon. So here, there's a picture of all of Titan. And then this is just looking at this little spot to create for the next one. And so you can see the scale here. 1 kilometer is just that size. So that's looking at a region that might be the size of Omaha, let's say. You know, so the city of Omaha would fit in that picture. And then zooming in on just a little region there, we see a surface that looks pretty barren. Looks desertish. It's not, well, it is and it isn't. It's dry. It's really, really cold. So, you know, the desert does get cold at times. But it's considered, I think, a potential place that if the sun goes red giant, which, you know, it should in another 5 billion years, possibly you could, you know, live out there on Titan because its temperature would be warmed up and it would form an atmosphere and, well, you'd have to change the gases, I'm sure. Uranus. Uranus is twice as far from the Earth as Saturn. So Saturn is twice as far as Jupiter. Jupiter is about 10 times the distance from Earth to the sun. Saturn is twice as far. Uranus is twice as far as Saturn. And it's crazy. It's tilted. I should have done a different color. It's tilted so that its axis of rotation is 98 degrees to the orbital plane. Now remember, Saturn rotates backward. Or not Saturn, excuse me, Venus. Rotates backward very slowly. Uranus is on its side. It takes Uranus 84 years to orbit the sun. What causes us to have summer and winter, to have seasons? I haven't answered this question, I don't think. It's the Earth's tip. We're tipped 23.5 degrees from the plane that we orbit around the sun. And because of that tip, on somewhere around December 21, the sun is on this side, and up here in the northern hemisphere, we're tilted away from it. And so we receive more glancing radiation from the sun, and hence it's cooler. We're not getting as much direct radiation. Conversely, if you go 6 months from December 21, you're around June 21, you have the northern hemisphere is tilted toward the sun, receiving more direct sunlight, more heating. So we have summer. Summer starts at what we call the summer solstice, when the Earth's tilt axis in the northern hemisphere is as close as it can get to point toward the sun, and winter solstice is the other way around. So that's when we start summer, when we start winter. Spring and fall, by the way, start at the equinox when the sun is here or here rather than pointing toward north or, you know, on the direction north or south is. So here, if it's tilted 98 degrees, for all intents and purposes, we could treat that as 90 degrees, right? 8 degrees is not a big shift as far as we're concerned. So if it was tilted 90 degrees, how long would the summer last on Uranus? It would have significant summer. You'd have significant summer because there would be a time when the axis is pointing right at the sun. If you're at the North Pole, you would have direct sunlight all day long. And it would be summer for half of its orbit. So half of 84 is 42. For 42 years, it'd be summertime. And then you would have the equinox, and then it would be wintertime for the next 42 years. And you would have continuous sunlight if you were on the pole. Continuous sunlight for 42 years. And then no sunlight for 42 years. That would be bizarre weather, right? Of course, it is a gas giant. There's no service. You couldn't live there. Did you have a question again? No, okay.
I know it's random when we're not talking about Earth anymore, but like my question is like I know there's some places. I don't remember. I was talking to one of the professors here at Union, and they said that there's a place in I don't know what part of Europe or something like that where the summer it's like the sun doesn't really go down or something like
Well,
that.
anywhere in the Arctic Circle, that's the definition. Anywhere in the Arctic Circle, because we're tilted 23.5 degrees, if you're within 23.5 degrees of the pole, then when you're close to the winter solstice, the sun will never rise. When you're close to the summer solstice, the sun will never set.
Yeah. In places like Ecuador, I think also that they it's pretty much warm all year round.
Ecuador is equatorial, hence its name.
Yeah.
And so if you're equatorial, the sun goes north of you and south of you. Because of that 23.5 degree tilt, if you are on the equator, the sun is never going to be at noon. It's never going to be farther than 23.5 degrees from straight overhead. Whereas here, we're 40 degrees north. Because we're 40 degrees north, when the sun is 23.5 degrees north, that still leaves us 16.5 degrees between overhead and where the sun is. And when the sun is 23.5 degrees south and we're in the middle of winter, 40 plus 23 is 63.5 degrees between overhead and the sun. In other words, it's only about 26.5 degrees from the equator or from the horizon to where the sun is. It's very low on the horizon. We don't even think about that. We just say the sun's in the sky. But it's pretty low, so we're not getting that much energy from the sun in the winter. Okay, methane atmosphere. Methane atmosphere is what gives it its blue color. You go to Neptune. Okay, that is Uranus, yeah. Neptune lies beyond Uranus. Its diameter is almost 4 times the diameter of Earth. So, got to be bigger. So there's 4 Earths for comparison. It still has a rock that's, I think, bigger than Earth in its core. And Neptune has basically the same atmosphere as Uranus. Slightly different concentration of methane gives it slightly different color. So Neptune is considered bluer, Uranus greener because of slightly different amounts of methane. I didn't actually talk about this today. I mentioned it when we first talked about planets. Select all of the planets, so you have to make multiple selections that have moons. Remember, you have to select them all and hit enter. It should all be like Rachel. Wow.
Why won't let me hit enter?
Well, you've already answered twice, so. I believe it's twice. It changes color every time you answer, and yours has changed colors at least once.
So maybe I don't have to. Maybe it's like,
Well, the first time you had multiple answers because you were the first one in, I was able to tell.
oh.
Okay, still waiting on Danny. I don't know how to answer that. Is it now communicating? There you go. Okay. Our answers, only one person was right. And I know that's Rachel because she was the second one in. All of these have moons. Earth has 1, Mars has 2, Jupiter has lots and lots. I'm going to put 4 plus lots. Saturn, I'll put 1 plus lots. Neptune, I'll put 1 plus lots. And Uranus, I'll just put lots. I don't think Uranus has a large moon. The numbers I put are large moons. Well, actually, I'll circle the large moons. Jupiter has 4 large moons. Saturn has 1. Neptune has 1. Earth has 1. Mars has 2 moons, but they're small. Remember I talked about Phobos and Deimos, fear and terror? Those are the moons of Mars. Jupiter, we saw the Galilean moons, Io, Europa, Callisto, Ganymede. Once again, I can't remember the order, even though we saw it. Saturn, its major moon is Titan. Uranus, its major moon is Triton, or Neptune's major moon is Triton. But then you have lots of smaller moons, captured asteroids, for all of the gassy planets. Why don't Venus and Mercury have moons? Some people conjecture that because of the sun, it makes it hard for them to gather them. Others, just luck of the draw. It certainly seems like there is a relationship there. Okay, same question almost. Select all the planets that have rings. Okay, waiting for Samuel and Mariah. That's what she had a minute ago. Well, I'm going to go on because we're out of time. All of the gas giants have rings around them. We think of Saturn, but Jupiter, Uranus, and Neptune all have rings around them as well. Okay, have a great Sabbath. I'll see you again on Monday.